Howdy guys, today we'll be talking about integrals and how to find particular solutions. So let's get started. Okay, let's work through this first example first. And just as a little refresher, let's see if we can take the integral of this, right? So we have f prime of x, but we want to find, let's say, f of x. So this is the derivative. We want to find what the function was originally before it was derived, right? So we kind of know that the opposite of derivative is the integral. So we're just going to go ahead and take the integral of f prime of x. That's going to be 1 over x cubed dx. Now, we don't at this point know how to get the integral of a fraction, anything with a denominator, but we notice that this is x cubed, so x to the power of something. And we can kind of cheat and rewrite this in a way that we do know how to solve. And in this case, 1 over x cubed is the same thing as x to the negative 3. Right? Because we add a negative to the exponent, you just flip the fraction. And in this case, we do know how to solve this, right? By using the power rule. And if you don't know what the power rule is, go check out my other video on it. Or, as a quick refresher, we know that the integral of x to the power of anything is just going to be add 1 to the exponent, divide by the new exponent, right? So, in this case, the exponent is negative 3. So we're going to add 1 to the exponent. Negative 3 plus 1 is negative 2. Divide by the new exponent. So that's going to be negative 2 as well. And again, we can't forget about this plus c. And let me just rewrite this for beauty's sake. I always like to make my math beautiful. So it's 1 over 2x squared plus c. And this, my friends, is what we call a a general solution, not particular, it's general. Because we have no freaking clue at this point what this c is. It could be any number. We don't know. But luckily, with a little bit more information, we can find out what that c is. Because, I mean, c is very general. It's kind of annoying. You want something exact. And we can find this through the initial condition right here. So the initial condition just tells us a little piece of information more about what the original function was. So in this case, it tells us when x is 1, our function becomes 0. And that's going to be super important. So let's write that out. When f is 1, the whole function comes down to 0, right? But we notice that we just did find f of x. I mean, there's a random c in there, but this is still an accurate f of x right here, right? So notice how I can also take, on the other side, this fraction right here and derive it from f of 1 right there, right? And all I had to do to get f of 1 right here is to just replace every x with a 1. So that's what I'm going to go ahead and do, right? I'm going to take this, plop it in here, and have it with 1. So it's negative 1 over 2 times 1 squared plus c. Now take a moment to really absorb this, because this right here is the crux of the initial condition. Finding a particular solution with an initial condition. So in the end, this right here is also f of 1, this whole thing. So in this case, it's just plug and chug. We just use simple algebra in order to find out what our c is, right? So 0 has to be equal to negative 1/2, because 1 squared is 1, and then 1 times 2 is just 2, plus c. So c must be equal to 1/2. So we found a result for c. It's no longer a mystery to us. So we can rewrite our entire function as f of x is equal to negative 1 over half squared, x squared, plus 1/2. And this here is what we call a particular solution. Right there. So let's go over another example here. Okay. And this I find to be a very common AP question, so make sure you understand this. right? And I'll walk you through it. So first, it tells us a ball is thrown upwards with an initial velocity of 64 and an initial height of 80 feet. Now, immediately as I'm reading this word problem, the word that popped up to me was initial, right? Initial, when you see initial or something like that, boom, think initial condition. And that will already give you a clue on how you're going to solve this problem, right? And then the question asks us, find the position function given the height as a function of time. And then when does the ball hit the ground? So this is two-parter. So there's some background knowledge involved. At this point, hopefully we know that the position is related, that each one is related to the velocity, and the velocity is related to acceleration, all through derivatives. So the derivative of the position is velocity, the derivative of velocity is acceleration, right? And then one like final piece of background knowledge that you should just memorize is that our acceleration is gonna be negative 32 feet squared over second. And that's acceleration due to gravity. If I throw from a building a ball just off the building, the acceleration is just negative 32 feet squared per second. And that's a value that you can just memorize. And it's probably not going to change for the end of time, you know? So, with the background knowledge involved, let's continue. So, I always like to write things out that's given to me um, in terms of math. So, let's convert this math problem of words into math symbols. So, a ball is thrown upwards with an initial velocity of 64 feet per second. So, I'm hearing velocity, right? So, we have velocity at this time 0. That's going to be 64 feet per second. And again, that's going to be the same thing as the derivative of the position, right? Furthermore, we have the initial height to be at 80 feet. So the height at times 0, that's 80 feet per second. Or sorry, just feet, right? And importantly enough, we know the acceleration already. So all it takes us is to just work our way backwards from acceleration to velocity to position, and we'll have our answer because position is what we want, right? So let's first go from acceleration to velocity right here. So our acceleration we've already described is negative 32 feet squared per second over second. And it's negative because it's going down, right? And we have to make sure we have the negative sign. That's kind of a common mistake because our velocity, it was specified it's going up. So our initial velocity is going up, but our acceleration is going down. So we have to make sure that our symbols stay consistent in that way. So we see our velocity represented with positive sign, and our acceleration is represented with a negative sign. So if I want to know what the velocity is, right, which is just s prime of t, all we have to take is the integral of the acceleration, right? Because our acceleration, as denoted right here, is just the double derivative of position, right? So we kind of see that relationship between here and here, right? Because the integral is like the opposite of like a derivative. Right? So let's go ahead and do that. So I'm just going to plug in this negative 32 feet in here. And we know that when it's just a constant and we take the integral of that, all I have to do is tack on a t, right? Because t is our basically variable, as we can see here, dt. Perfect. And then we have to tack on that plus c. Perfect. But again, we don't really want to work with c's. If possible, we want to be working with actual numbers. And luckily, we were given an initial condition in order to resolve the c into an actual number. So we know, as denoted right here, what the initial condition of a velocity is, right? So we have v of 0 is equal to 64. And this is also v of t, right? So I'm just going to plug into this function 0, right? So we're going to do negative 32 times 0 plus c. And this here is also v of 0. Doo-doo-doo. So now we just solve for c, right? Negative 32 times 0 is just 0. So 64 must equal c, right? And this right here is one solution. So we can go ahead and replace our c with 64. So now we have negative 32t plus 64. That's our vt. And we're going to go ahead and highlight that. Wonderful. But we're still not done yet because we want our position, right? But luckily for us, we know that v of t is just the derivative of the position. So to just get the position, all I have to do is take the integral of v of t dt. It's the same thing as the derivative, right? So I'm just going to go and replace that, negative 32t plus 64 dt, right? And now I'm going to go ahead and integrate this. So again, this t, we're gonna see visually if there's like it's t to the 1, right? The 1 isn't explicitly there, but we know. So I'm gonna use the power rule here. So negative 32, a constant just rides along, is here for the ride, right? And we're gonna add 1 to the exponent, divide by the new exponent. So that's add 1 to the exponent, so 1 plus 1 is 2. Divide by the new exponent, which is 2. And then we have plus 64. It's just a constant, so we're just going to tack on that t. And then we're going to just do plus c. Oh, sorry. C2. We don't want this c and this c right here to be the same symbol because we want to mathematically make sure we understand that these are two different numbers. Because or else we would just say, oh, so it's 64t plus 64. That's what c is. No, these are two different numbers. Okay, and I'm going to go ahead and simplify this because we know negative 32 over 2, that's negative 16. So negative 16t squared plus 64t plus c. And that right here is just going to be our position, right? But again, oh, c2, yeah. But again, we don't want just a c2 in there, right? But we have another initial condition denoted right here that s at 0 is 80 feet. So we're just going to plug and chug and get s at 0 from this function that we just found. And we're going to find s at 0. So just going to replace every one of our t's with 0. So that's negative 16 squared, or 16 times 0 squared, plus 64 times 0, plus c2. And in this case, we see that 64 times 0 and negative 16 times 0, that's all 0. So we have in the end, c2 equals 80. So now we can just write more explicitly. St is negative 16t squared plus 64t plus 80. And that's from combining these two pieces of information. And this right here is our result. It's our final result right here. Yay! That's part A. Okay, but now we're asking part B, when does the ball hit the ground? So, like, threw our ball, it went up, it's down, and at the point that it hits the ground, the position is going to be 0, right? Our ball is going to have a height of 0. Do we agree with that? So all we have to do is, the question really is asking in mathematical form, in when is S of t going to be 0? At what time will the position be 0? That's what this is saying. And we can do that pretty simply mathematically, right? So we're going to go ahead right here and just solve for that. So S of t equals 0. So we're going to go ahead and substitute. And then we can plug this into our quadratic equation, a complete square, FOIL, however you prefer, you know? But in the end, just trust me, it's going to come out as negative 1, 5. And you can plug that into your calculators if you don't believe me, right? These are our two results that we get. But we know that the time can't be negative 1 because time can't be negative, at least not in this case, right? So we know that the ball hits the ground at 5 seconds. And that right there is our results. Make sure to put your units. That's another easy way to lose points in the AP exam, right? No, just put those units. And yeah, I hope you learned a little bit more about integrals and have an amazing rest of your day. Ciao.